Hello friends, welcome back to my YouTube channel MS Maths. My name is Manoj Solanki and I will start group theory. In this particular video, I will discuss basics of group theory and this is the part 1 of the basics. In this particular video, we'll discuss sets and its mapping and then division algorithm, GCD and LCM, and also we'll discuss prime number. So this is all about the basic of group theory and it is helpful for these many exams. So you can use for these all in all these exams. Okay. So basically, I will start from the basic. What are the sets? What is the mapping and all? Okay, first of all, what is the classification of set? I will start with the classification of the set. So set, we all know that set is nothing but a collection of all well-defined elements, or we can say some collection of element which is something has meaning, which is basically well defined. So if I am going to start with set, and set is basically from, I will start from the the complex number. Because of that, we have a greatest set, that is complex number. If I will start from complex number, that is something like countable, we can easily consider the set of complex number we can consider. So if it is a C, okay, this is nothing but a set of complex number. Okay, set of complex number. If it is a set of complex number, then it has a form, that is x plus iota y. Okay, where we all know that this x is nothing but real part and this is nothing but imaginary part. It means it has two values, but remember where my x and y are belonging from real number, because in this particular case x and y all are my real numbers. These are not imaginary. This particular complete number is called imaginary. Okay, now other than this, if I will take two part from here, I have two part. One is imaginary part, so one is imaginary, okay, imaginary number, which is something plus minus iota of b. Okay, if I, or plus minus iota of y, we can take where y belonging from again real number. And again next one is real number, or set of real number, which we will denote using this particular r. Okay, so again in this r we will have two kind of numbers, so which is basically we can consider as irrational number. Okay, irrational number and rational number. Okay, irrational number kind of pi we can consider. Okay, root 2, root 3, whatever we can take, these all are irrational number. We will denote it using q of c. And rational number, we all know that it has again two part. One is fractional. Okay, one is fractional. We'll write just in p by q, where q is not equals to 0 and q is also not equals to 1. We will take it as q is not equals to 1. It means, for example, 1 by 2 we can consider as fractional part. Okay, 2 by 3, 4 by 7, whatever. And another one is integer. Again, now rational number is denoting using this q. So next target is integer. What do you mean by integer? So now integer is something like this. We will denote it using z, and set of integer has three part again. What is that? First is that positive. Okay, positive, and we can consider 0, and we can consider negative part. In this case, we can consider this positive as natural number. Okay, we can consider it as set of natural number. How it is a set of natural number? Because it is nothing, it will start from plus 1, 2 and go up to infinity. This is the positive part, and this is what my 0, which is a singleton set. It is a singleton set, it is 0. If I will take union of all these three, then I will get set of integer. So from here I can consider that this one is my biggest set and its subset is r, and this r is made up of with irrational number and rational number. And then after going to the integer, it is a part of negative, 0 and positive, which is nothing but your natural number. So if I will write the order, so first of all I will write natural number, which is a subset of integer, okay, which is again a subset of q, and it means rational number, and this is nothing but a subset of real number, and this is also subset of complex number. This is what the order of set in which we are putting the order in the increasing order of the cardinality. Okay, whatever the cardinality, it has the greatest cardinality and it has the lowest cardinality. We are denoting using the alpha naught. This is what about the classification of fundamental sets. These are the fundamental sets. Okay, now next coming up to the mappings. Because of that, if we are defining any function from a to b, if it is a function, then here it is what? Domain. This is my domain and it is what? Codomain. Domain is something in which we are putting, from where we are taking the input for the function, because this function is nothing but a machine. We will just put some values and we'll get some values. So that is what, from where we are putting the value, that is called the domain. From here we will take input for the function, and this is what codomain. This is nothing but my output. Okay, this is all about the functionality of function. After that, one concept is there, range. What do you mean by range of function? So range of function, it means that it is related to codomain. It means it is related to the b here. So range is something related to that, how many elements of b which is related to a. It means whose pre-image exists in a. So whatever my function, I can just denote my function as like this. It is my domain and it is my codomain. Okay, here are some element and here are also some element which is related like this. So this is the mapping called function f. Now how many elements are there, or we can say a set of elements of b, a set of element. Let's say this is a set of element. These are the element which is exactly related to, let's say which is exactly related to a. Okay, these are the particular elements of b which is exactly related to, or which has a pre-image. Just see, which has a pre-image in domain. Okay, the element of codomain which has a pre-image in domain, that's like set of that particular element is called range. Okay, so it is this means the set of all those element or elements of b which has pre-image in domain. Okay, or which elements of b, or whatever the b is nothing but codomain. B is nothing but my codomain. This is what the concept of range. Why I am discussing this? Because of that I want to discuss one-one mapping and onto mapping. What are the one-one mappings and what are the onto mappings? For that we need the range of function. Okay, now just discussing the one-one mapping. Let's say I have one function f of a is f is nothing but a to b, a function. This function is 1 1. Sorry, this function is 1 1. Why this function is 1 1 here? There are two property. It says that if you are taking any of x from a, this x1 and x2 from a, let's say my x1 and x2 are belonging from domain. It means these are my inputs. If these both are equal, let's say my x1 is equals to x2, then function value of this, it means if I will take the value on that function, that also should be equal. Okay, if these both are not equal, then this should not also equal. Okay, this is the concept of one-one function. And if I will draw using the diagram what is the meaning of one-one function, what is the graphical, or we can say image, I want to show you the how this will look like if it is a and if it is b. So what is my 1 function? Whatever the function I will take, if here are, let's say, 4 elements and here are also 4 elements, then this element is relating to this element is this and this. So this is nothing but 1-to-1 mapping. It means that my this particular element is mapped with 1 only. Each element is mapped in B with only a single element. That is what the case. Let's say it is my x1 and it is my x2, and this is my f of x1 and this is my f of x2. Now you can see if these both are not equal and also these both are not equal. So this is the case of 1-1 function. Whatever the example we can take, for example, f of x is equals to x. If I will define my domain with the natural number. Okay, I will define, wait, I will define my domain, let's say, one second, let's say a function from natural number to natural number. So it means I have defined the domain, so I can take x is equals to 1, so it will be 1 and 1. If I will take x is equals to 2, then it is 2. Now you can see here 1 is not equals to 2, it means f of 1 is also not equals to f of 2. How the graph will look like in this case? So the graph of this is nothing but like this. This is a y, or we can say f of x is equals to x. Here if you will take x is equals to x1 is equals to 1, here you will have f of x1. It is what my x2, it is what f of x2. So this is the property called 1-1. If you are taking input from domain, that is 1, and if it is not equal, then the function value of both the points are also not equal. This is the concept. Next, we have the concept of onto mapping. Now, what do we mean by onto mapping? That we are also going to discuss. So, here, all the element, we have what? Y belonging from B, there exists A belonging from A, such that f of x is equals to y. This is for all, basically. It is saying that for every element of B has a function or a pre-image, or we can say f of x, we can say f of x is equals to y, where x belonging from A. It means each and every element of codomain should have a pre-image in domain. It means simply that if it is A, if it is B, it means that how many elements are there? Let's say n elements are there. So it means all n elements should have pre-image in domain. Okay, all n element of codomain should have pre-image in domain. Okay, that is called onto function. Onto means it is completely overlapping to that particular set. It means that I can just simply say my range of function, let's say this function is f. Now what is the range of this function? Those element of B which has a pre-image in A. It means my range of this particular, let's say this is the range of this function. If it is equal to the set, okay, if I will denote like this, if it is B and let's say I am denoting it as a range, if it is going to equal this particular set, if it is going to equal this particular set, it means now my range is going to be the whole codomain. That's why we are saying that if range of function is equals to codomain, it means all the output will be covered in the range. That's why we can say that is called onto mapping. Okay, this is the example of this is the basically 1-1 and onto mapping. Next we have one example, and we'll discuss how it is a 1-1 or not a 1-1 function. Okay, just solve this question. We have a function from natural number to integer. It means we are bounded with that. We can take inputs from natural number only. We can't take input as 0. We can't take input as negative number. We will take input as input from the natural number, and we'll get output from the integers. Okay, now my function f of x is what? X square. Okay, is it a 1 1 or not, that we will see here. So first of all, if I will put x is equals to y, let's say my x is equals to y, then what, f of y is equals to y square. Okay, if my x is equals to this, if my x is equals to f of y is equals to y square. If I will take any negative, or I can't take like, by the way, I can't take any negative number. So in this case, if I will take like x is equals to, or if I will find out any value from here, let's say there is a particular method to find this. If I will take y is equals to x square and x is equals to root of y. Root of y means it is a plus of minus y. Okay, now here I can just write, if my x is equals to y, then f of x is equals to x square. If my x is equals to y, then I can easily say my f of y is equals to y square. If my x is equals to minus of y, then f of minus y is equals to again minus y whole square, it is also y square. Okay, from here I can easily say that this will be but one thing is that here it is equal. If I will take x is equals to y, if I will take x is equals to minus y, it means these both are not equal. It means the function value should not equal. F of y should not equal f of minus y. But here it is what, y square, and it is also y square, it is equal. But one thing is that minus of y does not belonging from natural number. It means it will be always 1 1 function. You can take example, let's say f of 1 is 1, f of 2 is 4, f of 3 is 9. If you will take any of the 1 is not equals to 2, it means f of 1 is what, should not equals to f of 2. Yes, 1 is not equals to 4. This is the concept. You can prove by the contradictory, or you can prove using the example, and simply we can say this is a from, okay, yeah, from the result we can say this f of x is equals to x square, where n to z is a 1 1 function. This is clearly a 1 1 function. Okay, next we have one more example. Yeah, now this is what, z10. Now one thing is that, remember, just keep in your mind, what do you mean by z10? First, what do you mean by z? Z is nothing but set of integer. Set of integer means it will contain from 0 plus minus 1 plus minus 2 and up to infinity. What do you mean by this? This is basically the positive, and it will take modulo 10. Now what do you mean by modulo 10? Let's say, first just let me take the example. What do you mean by z2? Z2 have cardinality 3. It will contain 0, 1 and 2. If it is 3, let's say if it is 3, okay, if it is 3, then again it will be 1. How it will be 1? Let's say, what is my z? Z is plus minus 1 or 0 plus minus 1 plus minus 2, whatever. Now it is, I am taking mod, wait, I am just taking mod 2. Okay, now what is mod 2? Mod 2, okay, negative will not be considered in this. This will be always positive set here. See, mod will take only positive value. Now if I will take 3, so 3 mod 2. Now what do you mean by 3 mod 2? Means if you are going to divide this and just write here remainder. What is the remainder? If I will divide from here, my remainder will be only what, 1. Remainder will be 1. It means again 1 is repeating. If I will take 4, if I will take 4 and I will divide by 2, remainder will be 0, which is already in this. So this is called set of modulo, which is nothing but modulo 2. Now if I will take mod 10, now sorry, z10, what are the elements of z10? So it will be 0, 1, 2, 3, 4, okay, 5, 6, 7, 8, 9. 10 will not be there. Yeah, 10 will not be there. One second. Here also 2 will not be there. Sorry, here also 2 will not be there, because 2 by 2 will again 0 will be here. That's what the mistake here. Sorry for that. 2 will not be there. Now, this is my Z10. Now, it is saying that if I have a function from Z10 to Z10, it means I will take elements inputs from this particular set only. I can't take any value from any value other than this particular set. Okay, and the function is defined like this: f of x is equals to 4x. Now, is it a 1 1 or not? How can we identify 1 1 or not? It is just simple. We can just take any value. Let's say my x1 is equals to 0. From the definition, it means if my x1 is equals to 0 and my x2 is equals to 5. Okay, it means f of x1 should not equals to f of x2. Because of that, my x1 not equals to x2. Okay, this x1 is not equals to x2. Okay, now what is f of x1? It means 4 into 0, that is 0. Okay, now f of x2, it is what? 4 into 5, it is 20. But 20 is not in this set. It should be, see, output should be also in this 10 mod 10 na? Output should be also in z mod 10, but it is 20. So what we'll do, we'll just divide this 20 with 10. If I will divide it, then it will be 2 times and it will be 0. It means this 20 means 0 here. Okay, now you can see here this is 0. But okay, my x1 is equals to this, x2 is equals to this, then it means that it is not a 1 1 function. Okay, it is not a 1 1 function. It means my f of x1 is not equals to f of x2, but sorry, x1 is not equals to x2. It means f of x1 should not equals to f of x2, but here, but f of x1 is equals to f of x2. It means 0 is equals to 5, that is 0. So it is clearly, it is not 1 1, not 1 1 mapping. This is how we can identify this particular case. Next, we have one more question which is same related to this. Now, what do you mean by Z6 here? Z6 is nothing but 0, 1, 2, 3, 4 and 5. It means whatever you have Zn, it will contain n number of element up to n minus 1. For example, if it is Zn, then it is 0, 1 up to n minus 1. But the cardinality of this set, okay, but the cardinality of this set is going to be n, because 0 is also here. So the cardinality of this set is 6, but till 5, n minus 1. Okay, now my function is defining like this: f of x is equals to 5 of x. Okay, now I will take any of the x1, that is what, 0. If I will take x2, let's say 4. Then if I will find f of x1, now f of 0, it means it is 0. Now f of 4, it means it is 20. It is what? 20. Okay, then after I will just divide 20 by what is my codomain? Codomain is 6. Because of that, my output should be in that particular z6, but 20 is not in this, so I will just divide by 6. Then it is 3, 18 and it is 2. Yeah, it is not equal, but we can't make any conclusion with one example. With one example we can't make any conclusion. We have to check further. Because of that, if we are able to finding any of the contradictory in only once, then we can make conclusion. But from here I can't make conclusion. Okay, otherwise according to this, it is satisfying the condition, but I can't make strong conclusion here that it is a 1 1 function. So what will I should check for every pair? So should I check for every pair? Can I do that? So for that, we should have at least one thing is that in our mind. In this case, if I will take f of 0 or f of 1, let's say f of 1, f of 1, it is 5. Let's say f of 2, it is what, 10. Yeah, f of 3, it is what, 15. F of 4, it is what, 20. F of 5, it is what, 25. Now you can check from here, if I will find mod of each and all, it is 5 belonging from Z6. Yes, no need to take mod of this because 5 mod 6 is 1. Okay, means 5 mod 6 is going to be 5 only. Because of that, like this 5 is less than of 6. If it is greater than of, if any number of here which is greater than of 6, then we will divide and find the remainder for mod case. If it is 10, then we'll just divide by 6. Okay, remainder will be 4. So it is equivalent to 4 with respect to mod 6. I am taking with respect to mod 6. Okay, here it is also 6 2s are 12 and it is equivalent to 3. It is equivalent to what, 2, and it is equivalent to, if it is 25, 6 4s are 24. Sorry, yeah, 24 will be in 6 table, so it will be 1. So now you can see here, these all are the element which is not going to be equal to each other. Then we can say it is a function which is one function. Now see, what is the difference in this particular example? Here we have 10 z10 to z10 4x. Okay, here we have z6 to z6 5x. Now there is a one result which is something related to these both example. That is what, if GCD of a, whatever my function, let's say my function f of x is zn to zn. Okay, and my function is defined like this, a of x. Now I have two quantity here, one is n and one is a. If GCD of these both is going to be 1, GCD of these both is going to be 1, then my function will be one function. Okay, so the GCD of a and n is 1, then function is 1. If my function is defined from zn to zn and function is a of x. Now just come back to the example. What is my n here? N is equals to 6 here, and what is my a? It is 5. So what is the GCD of 6 and 5? GCD means that greatest common divisor. What is the greatest common divisor in this? Only 1. If it is 1, then it is a 1 function. Yes, it is a 1 function. Now come to this example only. It is what? N is equals to 10. Okay, now what is a? That is 4. Now what is the GCD of 10 and 4? GCD of 10 and 4, that is 2. That is 2, which is not equals to 1. It means it is not a 1 function. This is what one important result that you can see here. Next, we have one example. Now we can identify this, how many 1 mappings are there. This is what one of the important result. Again, will continue with this particular only. From Z15 to Z15, define a function. Okay, from my function is defining from f z15 to z15. It means my elements from 0 to 14 n minus 1. Okay, and f of x is defined such as ax. Now it is saying that how many 1 mappings are there. Now actually we have to find the number of 1 mapping. How can we find the number of 1 mapping here? That is quite related to same as GCD. We can just find the number, or we can just find the a, and also there is a criteria where a is also belonging from this Z15. Okay, a is also belonging from this Z15. Can I find such a which will make 1 mapping? Or I can find functions, or basically the number of function which will make 1 mapping in this particular domain and codomain. Yes, I can find. How can I find? So I will just take GCD of what? GCD of this a. Okay, GCD of this A with 15 is equals to 1. Okay, can I find A from this particular Z15? Yes, I can find. So whatever my A here, so A will be 1. If my A will be 1, then 1 and 15 GCD will be 1. If it is 2, yes, I can make. If it is 3, 3 and 15 GCD will not be 1 because 3 divide 15. Okay, 3 will not be there. Then 4, of course. 5 again, no. 6, can I make 6? No. 6 and 3 both are common divisor of 6 and 3 is, yeah, 6 and 15 both are common divisor of like both can be divided by 3. Then again 7 can be 8, of course. 9 can't be. 11, yes, 11. Okay, 12, no. 13, yes, 13 can be. 14, yes. So these are such A which will make a function, and in this particular condition which will make a 1 1 mapping with this. So how many? 1 2 3 4 5 6 7 8. So number of 1 1 number of 1 1 mapping. So number of 1 1 mapping in this case is 8. So these all are the value, these all are the case. One thing is that the GCD of 0 and 15, this is also going to be true. The GCD of 0 and 15, but just think me over that. GCD of 0 and 15, that will be 0, not 1. Yeah, it is correct. So 8 is the correct answer for this question. Even you can find using the result like these types of questions. Okay, next. Okay, again this is a same slide. Okay, so next we have a function f, z to z defined by f of x. Is it a onto function or not? Now what is the meaning of onto function? Which will cover, or basically we can say the range of the domain will be equal to this z. Now it is from z to z, or it is f of x is equals to x square. Okay, if I will take x square as this, and if I will take like values from integers. Okay, if I will take values from integer, and if I will put in this case, so if I will put x is equals to 1, it will be 1. X is equals to minus 1, it will again 1. Okay, it is not 1 1 in this case. Because of that, if these both are not equal, okay, let's say it is my x1 and x2, if these both are not equal, then this should also not equal, but it is equal, so this is not 1 1. Now what about the onto case? For onto, how can we check in this case? So for onto case, if I will take, let's say my f of x is equals to 3. Okay, so f of x is equals to x square, and f of x is equals to x square. What is x? X belonging from z. And what is f of x? It is also belonging from z, because this is my codomain and this is my domain. Okay, if I will take 3, then 3 is equals to x square, then this is what? Root 3, or plus minus root 3, and root 3 is equals to x. Does root 3 belonging from integer? Just see, does root 3 belong does root 3 belong from integer? It is not belonging from integer. It means this is not belonging from integer. The case is fail here. Now using the contradictory fact, you can easily contradict that. So this is not onto function. There is one concept that you using that concept, you can easily say that it is a onto or not. This is what? This is my x square, but that is applicable for only real number, not integer, because if it will be integer, then it is like that, it is not continuum. Real number will be continuous, because there is no hole in that real number, using the continuum hypothesis. So if any horizontal line which cuts the curve, because this is what? X square, which cuts the curve 2 times, then it will be onto. But in this case, this is not onto, because root 3 will not be the part of. Because of that, if I will take any of the point from the middle of these both integer, okay, there is no element in between 1 and 2 in integer, but in real number there are infinitely many real number in this particular interval. Okay, this is the concept here that we will discuss. This is what, using geometry you can identify my function is 1 1 and 1 1 or onto. Okay, that we will discuss later. Next we have one example. Is it onto or not? Before going to this, we should like we'll have one example again. We'll have like some result, so that we can discuss that result and then we can proceed forward. Similarly, let's say these all are not onto mapping. Because of that, there is one result. If my Zn to Zn, if it is defining on Zn to Zn, f of x is equals to a of x is onto if and only GCD of a and n is again going to 1. So on the case, on the same thing, that is what we have already defined with the 1 1 function, that is also working with this case. What is my n here? That is 6, and what is a here? That is 2. If I will take GCD of 6 and 2, that is not going to 1. Okay, that is not going to 1. It means this is not onto mapping. Okay, similarly with this particular case, this 6 and 6 GCD is not 1, this 6 and 6 GCD is not 1. Okay, this 0 and 6 also GCD is not 1. So we can say these all are the example with whom it will not make onto mapping. Now if I will take f of x is equals to 5x and my f from z6 to z6, now is it onto? Yes. Is it onto? As well as it is 1 1 function, because GCD is 1 in this particular case. This result is for only this kind of function, not for all the kind of functions. Chat like domain and codomain should be Zn. Okay, next we have like we can count, or this is nothing but the countability of function, that how can we find the number of mappings, like how many 1 1 mapping is there, how many onto mapping is there. We can easily find. Let's say my cardinality of domain is n and codomain is m. So if you want to calculate the number of total mappings from A to B, that is nothing but m power n. This is one of the important result, m power n. It means the cardinality of codomain power cardinality of domain. It means cardinality of codomain power cardinality of domain. Okay, let's say if n is equals to m, then we'll just find number of 1 1 and onto mapping. So if m is equals to n, let's say we can take one example, f of z6 to z6. So what is the cardinality of z6? That is 6. So how many 1 1 mappings are there? How many? So first of all, how many mappings are there? So it is 6 power 6 are the mappings. And now how many 1 1 mappings are there? That is n factorial. So this is total. Okay, this is, let's say if I will take example like this, 1 second. Yeah, if I will take example f from z6 to z6, then total mapping, T is total mapping, 6 power 6, this 6 power 6, or yes, if these both are equal. Okay, then 1 1 mapping, how many 1 1 mappings are there? That is 6 factorial, means n factorial. Okay, if it is onto, now number of onto mapping, that is also going to be 6 factorial. Now you can see here, this is a function which is 1 1 and onto mapping. So equal number of 1 1 mappings are there, equal number of onto mappings are there. This is what the basic concept. Okay, next, if it is n is less than m, it means my codomain is greater than the domain. Now let's say for this particular case, I can take example like this. This is my A, which is bit lesser than this is my B. Okay, now this is n and this is m. Now can you expect 1 1 mapping from here? Can you expect 1 1? Yes, we can expect 1 1 mapping, but can you expect onto mapping? Onto mapping means each and every element of this will have pre-image in this particular case. So it can't cover the whole codomain. It means that there will not be any onto mapping. Okay, there is no onto mapping. But how many one mapping are there? M C n into n factorial. These are the one mapping. And similarly, if the case arises like this, if my codomain is bit greater than of domain is greater than of codomain, this is n and this is m. Now here onto can be exist because it can cover the whole codomain, but here one mapping can't be exist because no element from here can't be remaining, we can say that. So it means that each and every element can't make the mapping with the codomain. Okay, this is what the example. And now exactly how many onto mapping are there, that is what summation r is equals to 0, m is equals m minus 1. Okay, r is equals to 0 to m minus 1, mcr m minus r power n. This is the formula actually written here. This is not showing clearly here, so that's why this is the number of onto mapping. This is what number of onto mapping which is in this case. Okay. Next, we have one example, that is what how many number of mappings are there. For example, this is a function in which is a to b here. So total mappings are basically 2 power 2, that is 4. Or if it is equal, then we can find the onto mapping also, that is 2 factorial. Okay, n factorial means that is 2 factorial. Okay, and that is 2. And 1 mapping, okay, 1 mapping is also 2 factorial means 2. So these are the result for this question. Next, we have partition of the set. So what do you mean by the partition of set? It means that if you have a set which is non-empty, okay, which has an element, at least one element, set P is called, this particular P is the notation of the partition of set X. If empty, or basically this, we can say empty set should not belonging from the partition. Okay, and again, if we are taking the union of all the partition of that set, it should be again x. Let's say if my x is equals to 1 2 3 4 5. Okay, and if I will find a1 is nothing but 1 and 2. Okay, a2 is nothing but let's say 1 3 and 4. Okay, a3 is nothing but 2 4 and 5. Are these all partition of my x? Yes, because if I will take union of all these, if I will take union a1 union a2 union a3, it means that, okay, it means that it will construct my x again. So this is what the concept of partition here. Okay. Next, we have one property is there. If A belong to P and like this one is here, like B belonging from P, and A and B are not equal, then A intersection B should be phi. This is one of the concept here. It means that partition should be unique. If I will take the intersection, let's say, so A1 is equals to A2. According to these two cases, just see, according to these two result, these are the partition. It means this is fulfilling this. But there is one more point in this case, that is what, if A is a partition, or this is set of partition, basically if A is belonging from the partition, B is belonging from partition, A and B both are not equal, it means the intersection should be phi. Now think over it, are these the partition? No, because of that there are element repeating. If I will take intersection of these both, then one is intersection here. This is the thing, if we will take union, we'll get x, but it is not partition. So partition will be unique. So partition for this is nothing but a1 which is 1 2, okay, a2 which is 3 4, and let's say a3 that is 5. Now these a1 a2 a3 are partition. According to these two result, it is looks like partition, but it is not exactly the partition. Why it is not exactly the partition of the set? Because of that there are element repeating. If we will take intersection of, let's say, intersection of this and this, 2 is here in common, so there should not any element in the intersection. So this is the wrong partition, this is wrong, these are the not partition, these are the partition of set A. Okay, next we have a set containing n plus 1 element. Okay, a set containing n plus 1 element, then the number of partition of the set. How many partition will be for that particular set? This is the result, and this is one of the result that p of 0 and p of 1 is equals to 1. Then we can find the partition of any of the element. Let's say if my p is n plus 1, it means a set containing n plus 1 element. We'll take example here. So a set containing 3 element, then how many partitions of the set? 3 element, it means my number of element. So the number of element is equals to 3. It means n plus 1 is equals to 3. It means my n is equals to 2. If my n is equals to 2 here, so I can just easily find here, if my n is equals to let's say if my n is equals to 2 here, then how can we find the value? N is equals to 2, a set containing 3 element, then how many partition of the set are there? Okay, so if it is n plus 1, then what is the formula here? Formula is NCR/PR. Okay, so the summation of n means 2CR. Okay, if it is NCR and P of R, 1 second, just let me check it. If it is 2, then we have to find, I think if a set containing 2 element, then how many partitions are there? So it will be 0 and up to 1. So if it is R is equals to 0 and this is up to n, and my n is 2 here, so 0 to 2 here, then it is R and P of R. It means what is this? 2C0 P of 0 plus 2C1 P of 1 2C2 P of 2. Okay, we have P0 and P1, but we don't have P2. So can we find P2 here? If I will find P2 here, so P2 means P of 1 plus 1. It means it is a summation. R is equals to 0 to 1, and it is 1C R and P of R. It means it is nothing but 1C0 P0 plus 1C1 P1. Because of that, we have P0 is equals to P1 is equals to 1. Then it is nothing but what? 1 factorial, we can say, yeah, it is 1. So 1 into 1 plus, it is what? 1 into 1. So it is nothing but 1 plus 1 is equals to 2. So my P2 is equals to 2. I have all the values. This is 1 into 1 plus this is nothing but 2. Okay, and this is going to be 1 and this is 1 and this is going to be 2. So what is the value? 1 plus 2 plus 2, this is 5. So my P3 will be, yes, this is nothing but P3. So P3 will be 5 here, that we can easily find here. Okay, now can I find set? Okay, this is for 2, that I have already done here. So my P2 is nothing but 2. Now can I find for P2, P3, P4? Just say this is the element. I have also find P2, that is 5. Oh, sorry, P2 is 2. P2 is 2. P3 is 5. Can I find P5? Yes, I can find P5. Sorry, P4. So P4 is nothing but P3 plus 1. It means summation R is equals to 0 to 3 and 3 CR/PR. Now, what do you mean by this? This is nothing but what? 3C0 P0. We have the value of P0. Okay, then 3C1 P of 1, yes, 3C2 P of 2, yes, we have the value, and 3C3 P3. we have all the values, we will put the value and we can easily find. Okay, similarly we can find P5. Yes, we can find P5, that is nothing but 4 plus 1, and because of that P4 will be here. You can put this value here. Okay, next can you find, yeah, what is the form of this? R is equals to 0 to 4, and this is nothing but 4CR. Okay, 4CR and PR. Okay, again what is P6? P6 is nothing but P5 plus 1. Because of that it is your P5. You will have all the value, you can easily find from R is equals to 0 to 5, and this is 5CR P of R. So this is how you can find the number of partition. Okay, and there is one note: number of equivalent set. Number of equivalent set, let's say my set has cardinality 6. Okay, set has cardinality 6, then how many equivalence relation will be there? Okay, there are like relations on the set, like equivalence relation, like equivalence means like what? Symmetric. Okay, we can say there are three relation in that particular case in the equivalent relation. Okay, so the number of equivalence relation is nothing but number of partition of that set. If the cardinality of 6, so how many equivalent relation will be there? So it is P6. So P6 number of equivalent relation for that set whose cardinality is 6. Okay, next we have division algorithm. This is what one of the important concept. Let A is equals to Z, B is equals to Z, and now here if my B is greater than 0, okay, if B is greater than 0, then there exist unique Q and R. Q is quotient, R is remainder in that Z, such that this is my remainder theorem. Okay, so A is equals to BQ plus R, where R in between 0 to A, 0 to B, R will be up to B. Okay, and Q is called quotient, equivalent, not equivalent. Q is quotient and R is called remainder here. So here let A is equals to 15 and B is equals to 4. Okay, so my A is equals to minus 15 and B is equals to 4. Let's say B is greater than 0 here. So what is the division algorithm says? That it is what? Minus of 15. Minus 15 is nothing but 4 into minus 4 plus 1. So this is your if will equivalent. So A is nothing but minus 15, B is equals to 4, which is greater than 0, Q is equals to minus 4, and R is equals to 1. This is the division algorithm. Now here are the extended division algorithm. Means that if your B is non-zero, it means if you are dividing A with B, first case is this: B is greater than 0. Second case is this: B is not equals to 0. It means my B can be greater than 0, B can be less than 0. This is called extended division algorithm. Now it is what is the difference here? If you will take R value, it will be mod of R. Because of that, if it is minus of 4, then it will again up to 0, 1, 2, 3. Not 4. Okay, up to 4. There is no equal here. There is just less than of that. 0 can be there. Also there is no equal. 0, 1, 2, 3. Okay, 4 will not be in the remainder. Okay, if it will mean remainder, it will shift to the quotient. This is the simple concept of the division algorithm. Now come to the concept, that is the greatest common divisor. It means GCD. Let A is equals to 0, B is equals to 12, and you are going to find the GCD. How can you find the GCD? GCD means that greatest common divisor. Okay, greatest common divisor, then divisor of, we'll just find the divisor. So divisor of 0 is what? Plus minus 1 plus minus 2. 0 is not the divisor itself. Okay, 0 will not be divisor for any of the number. So plus minus 1 plus minus 2 plus minus 3, these all are the divisor of 0. These all will divide 0. And again the divisor of 12, it is what? Plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 and plus minus 12. Now we are finding what? Greatest common divisor. Okay, which one is common here? Plus minus 1 is common here, plus minus 2 is common here, plus minus 3, 4, 6, all are common. Okay, this is what? The common divisor. Now we are finding the greatest common divisor. So among these, this is greatest, The mod value is greatest, obviously. So this is the GCD of this. So it means the GCD of any of number with 0, that is the GCD for that. It means 0 GCD 10 will be 10. 0 and GCD of 0 and 100 will be 100 only. So this is the concept here. So if you are going to if you are taking GCD of A and B, if you are taking GCD of minus A and B, A should be same. It means GCD of 5 and 7, GCD of minus 5 and 7, okay, GCD of plus 5 and minus 7 will be equal to the GCD of minus 7 and minus 5. These all are equal. Again, GCD of 0 and 0 does not exist because 0 will not be divisor for any of the number. Okay, this is for the concept here. Next, we have the definition of GCD, which is nothing but if you have, okay, see, A and B both are non-zero integer. These are not zero integer. If it is 0, that case we have already discussed. Okay. Then greatest common divisor of A and B will be a positive integer. Okay. If D divides A, D divides B. Okay. D divides A, D divides B, and if such C is A, C divide A, C divide B, then that C also will divide D. Greatest common divisor means that which is the divisor, which is the number. Okay, here D is GCD. It means this D is greatest number which will divide A and B commonly. No any number which is greater than of D which will divide commonly to A and B. This is the simple meaning of GCD. Okay. Next we have Euclidean algorithm. This is called something Euclidean lemma. Okay. I have some calculations for that. Euclidean lemma. Okay, now what do you mean by Euclidean lemma? This is simple based on remainder theorem. If it is A is equals to BQ plus R, and now your R is nothing but 0 to mod of B, if I will take the extended theorem. Okay, now from here, let A and B both are two positive integer, then there exists unique Q and R in integer such that A is equals to BQ plus R, which is remainder theorem. Again, it will not equal, it will be mod. If we are taking positive integer, then no need to take mod here. Okay, no need to take mod here, just take B only. Now, this is the concept. I will show you using the example. Just see. Here it is what? Let's say I want to calculate the GCD. What is the Euclidean lemma? It is the lemma or Euclidean algorithm which will be used for finding the GCD for the large number. If it is that 1, 2, 3, 7, 8 and 3054, if I want to calculate the GCD, that will be 6. How can I find? So just simple, write it as A is equals to BQ plus R. It means I will just divide A with B and I will find the quotient and remainder. So my remainder is 162. And now if my remainder is 162, then I will just replace this number here and see this number here and this number here. It means now I will, one second, what is this going on? Yeah, it means first I will just divide this with this number, then I will replace this here and I will divide with remainder only. Okay, then after what will I do? One second. Yes. Yeah. Then after what will I do here? From next again in this quotient or in not in quotient, in this B I will divide the remainder and again find the remainder as 24. If I will divide 138 with 24 into 5, okay, plus will be here. Wait, there is plus, one second, there is plus here. Yeah, so here my remainder is 18. Now I will divide 24 with 18, I will get remainder as 6. Again, if I will divide 18 to 6, then I will get remainder as 0. So you have to proceed till the end if you are not getting the 0. Okay, So you have to proceed with the 0. If you are getting 0, then what is your last divisor? That is 6. That will be your GCD. This is nothing but the Euclidean lemma. You can easily find it out here. Next, solution of linear equation. Now how can you find the solution of any of the linear equation using the Euclidean lemma only? So if GCD of A and B, D is the GCD of A and B, then there exists X and Y in Z, which is something like of this GCD in the form of AX plus BY. We have one question. Let's say it is a tan. Okay, let's say question is tan is equals to 2x plus 3y. Now find the value of x and y. What is a and b? First remember, a is greater than of b. So my a is 3 and b is equals to 2. I will find the GCD. Okay, I can find. So it is what? 3. I will divide with 2 into 1 plus 1. Okay, again in this 2 I will divide with 1. Okay, now I can easily find the GCD of 3 and 2 is nothing but 1. It means my D is equals to 1. Now can I write like this? D is equals to, what is my A? A is 3. 3 into x plus B, sorry, not B, 2 into y. Okay, can I write like this? Yes, my D is 1, then 3 into something. Okay, here it will be x and it will be y, plus 2 into something. Can I make this form as 1? Yes, if I will write 1 here, it will be 3. And if I will write minus 1 here, it will be what? 3 minus 2, which is nothing but equals to 1. So I can easily find that is nothing but my x is equals to 1 and y is equals to minus 1. But here see, it is 10. It is not equivalent to this. So I want to make this particular value so that I can compare. Now I can't compare. But if I will multiply this with 10, so it is 10 is equals to 3 into 10 plus 2 into minus of 10. Now just can I say what are the value of x and y? Yes, I can easily say x is equals to minus of 10. It means 2, the coefficient, whose coefficient is 2, that is x. So x is equals to minus 10 and y is equals to 10. This is the one of the method you can easily find the solution of system. Now this is the question related to the linear equation. If we have one linear equation, ax is equals to b, y is equals to c, has a solution if and only if d divides c, where d is nothing but the GCD. Let's say first of all we have this linear equation and we are asking about this equation, that find the solution or x and y for this particular case. Now can we find x and y for this case? First of all we should have an idea about this, does the solution exist or not this particular case. Okay, we'll just find. So it is what is my a here? A is equals to 49 and b is equals to 7. We will just find GCD. Okay, so GCD of 49 and 7, it is easy, that is 7. Now this is what C. What is C here? C is 18. Can my 7 divides 18? Of course not. It is not dividing. It means there does not exist solution. There is no solution for this particular example. Now for this case, can we find the solution? Yes, we can find. Okay, GCD is given here. Can GCD divide 100? This is my C. Okay, yes, it is dividing. It means there exists solution. Now if there exists a solution, can you find the solution here? Yes, I can find the solution. I have one calculation here. I don't want to make like calculative part here. So if it is 172, then I will just write it as 172. If I will divide with 20 and if I will multiply with 8 and plus 12. Okay, multiply with 8 and plus 12. Okay, that will be okay. Next, if I will find 20, if I will divide 20, then I can easily find. I have already calculated the question, that is 12 into 1 plus 8. This is nothing but simple. If I will divide 12 with 8, and this is going to be 8 plus 1, okay, and plus 4, and again 8 is equals to 4 into 2 plus 0, and from here we can find GCD is nothing but 4 because last divisor is 4. Now from here can I find like this? Now what is the result? That d is equals to ax plus by. Now what is d? That is 4. Okay, now what is a here? A is 172 into something here, and next is 20 into something here. Can I make this form as 4? It is very difficult to assuming, and it is very difficult to thinking that what value will suitable for this. So for that, to avoid that thing, you have to just replace this x and y here. So there is there is again calculation part here. I will just write like this. Simply I will start with this part. Where is the 4 coming here? Okay, can I take this equation from here? So it is what? 12 minus 8 into 1 is equals to 4. Can I like this? Because it is like this, something d and something like this. Okay, now from here, can I make this 12 minus 8? What is my 8? From this equation, can I replace this 8 with 20 minus 12 into 1 is equals to 4. I have just replaced this 8 with this expression. Okay, then after, what can I do? From here, I can just write, I can just see it is what? If it is 12, and okay, I will just simplify it. It is 12 plus 20 plus 12, and if it, okay, yeah, it is 4. Now can I write like this? Again, it still, it is a it is not, wait 1 second, there is a mistake here. Minus of 20, yeah, not plus 20, minus of 20 will be there. Yeah, now it is equivalent. So can I write like this? 12 into 2, like 24, minus 20 into 1 is equals to 4. Now can I replace, can I use this equation? So 12, instead of 12 I can just write 172. Because of that, I need this number and this number. See, I have come up with this number, that is 20 in my expression. Okay, but 172 is not there. I will just bring that 172 as the form of this 12. I will just replace this equation, that is 172 minus 20 into 8, 20 into 8 into 2 minus 20 into 1 is equals to 4. Now can I write, can I make any expression from here that will be something related to 172 into 2 minus, and this will be what? 20 into 8 into 2 minus 20 into 1 is equals to 4. Now see, from here what can I do? Can I arrange this expression like this? I just want this only. So 172 something here plus 20 and something here. I can easily make from here, that is what? Nothing but 172 into 2 plus 20. Okay, from here if I will write like this, this is what? 20, this is what? 20, it will be 4. Okay, I will take like this 20 and twice of 20, that is 20 into 2, 20 into 2, and this 2 will be 4. So this is going to be like 172 into 2 and 20 into, okay, here it will be 2 and here it will be 4, like something like that, and after that it will be 4 equals to 72, and yeah, it will be minus 4. Minus 4 will be here. Now just see, from here it is 4, it is not 100. In the previous video also we have multiplied with 10, and now here if I want this 100, it means I will just multiply with 25 in both the side. Okay, into 25. So here minus 4 into 25. This is all calculation part. You just need to understand the concept. How am I proceeding here? Like what is the procedure? First I have find like GCD. After that I have made this. In the previous video, this was very easy to construct this kind of setup, but here it is not easy. So that's why I have started with the simple one, and then I have just brought all the values like this. I want to bring this 172 and this 20 into the form, so that I can make this form and I can proceed with this. Okay, this is all about the this particular solution of equation. Okay, now next we want to find the prime number and co-prime number. We'll discuss with this. What is the prime number? So prime number is something which has exactly two factor. Which factor? That is also specified, which is something 1 and itself. Let's say 2 other than 1. Okay, this is what? N greater than of 1. So if it is 2 is a prime number, it means it is 1 and 2. It has divisor only itself and 1. So let's say 3, it has also 1 and 3, only 2 factor. 7, 5, 13, 11, whatever you want to take, 23 you can take. Okay, next one is co-prime number. What are the co-prime numbers? So two integer a and b are relatively prime, or we can say co-prime. It means those numbers or those integers whose GCD is 1. For example, GCD of 5 and 7, it is what? 1. GCD of we can say 2 and 3, it is also 1. This is nothing but what? This is the relatively prime number. You can take 2 and 7, you can take 5 and 3, it is also relatively prime number. Okay, next we have there are exactly two integers which are relatively prime to 0, relatively prime to 0, that is 1 and minus 1. These are the only whose GCD with 0 is 1 only. Because of that, if you are going to take whatever the result, if you are taking GCD with any number, that GCD of 0 with any number, then GCD will be that number. Okay, if you are taking GCD of any 7, then GCD is 1. But for relatively prime number, it should be 1. So it will come up with only 1 and minus 1. Okay, so 1 and minus 1 are only two numbers or two integers which will be relatively prime number with relatively prime, or we can say co-prime with 0. That is 1 and minus 1. All integers are relatively prime with 1. Yes, if you are going to take GCD of 1 and 7, that is 1. Okay, again, that is all integers are relatively prime with 1. Okay, next GCD, if you are taking GCD of any of 3 number, then it means you are taking GCD of any of 2 number with the third number, that will be equal. This is the simple meaning of this line. Okay, next, at least, okay, one, the condition is at least 2 should be 0. At least 2 should be non-zero. Okay, not equals to 0, we can say. One, let's say you can find GCD of A, B and 0. But you can't find the GCD of A 0 0 because there is no GCD of 0 0 here. Okay, this is, you can't, this is wrong and this is correct. Next one is twin prime number. So twin prime number P and P dash both are twin prime number, rather than P dash is greater than of P, said to be twin prime number. The difference between these both is equals to 2. For example, yeah, 3 and 5. If it is 5 minus 3, that is 2. 7 and 5, that is again 2. It is also twin prime number. This is all about the result. Next, we have least common multiple. It means LCM. LCM is something related to that, which is basically least, or we can say least common multiple. It means that is the particular number which will be divided, or that is the particular number or the least number which will be divided by A and B. Just understand the concept of GCD and LCM. It is quite different. This is the highest or greatest number which will divide both A and B. This is divide A and B commonly, and this is the greatest one. There exist so many number less than this particular number which will divide A and B commonly, but this is the highest number. This is the number which will be divided by A and B. and this is the least number. There are so many numbers greater than of this which will be divided commonly with a and b, but this is the least number or starting number which will be divided from a and b. This is the difference between GCD and LCM. Here LCM does not exist for 0 and 0, LCM does not exist with 0 and 0. You can find GCD with 0 and 10, that will be 10, but LCM does not divide. Okay, again LCM of 2 6 is 6, LCM of minus 2 and 6 is 6, LCM of minus 2 and minus 6 is also 6. Okay, this is the concept. Now what is the relation between GCD and LCM of a and b? If a and b both are integers, that is positive integer we can say, so in that case your LCM and GCD, the multiplication will be equal to a and b. If it is not greater than of 0, it means if these both are non-zero. If it is non-zero and if it is also non-zero, then again LCM and GCD is equals to the mod of, because these both are positive quantity, this will not be negative, this will be multiplied with this, it will be equal to the multiply of a and b and the mod or the modulus value of the multiplication of a and b. This is all about the topic, and thanks for watching my video. Keep watching MS Maths. I hope you are understanding the concept whatever I have explained. So thanks for watching my video. Please like the video, share the video, and subscribe the channel. Press the bell icon. Thanks for watching my video. Keep watching MS Maths. Take care. We'll see you in the next video. Thank you. Bye bye.